All right, let's see what we've got. This is lesson 8990. These are the ones that were marked incorrect. So let's see what's going on. So we've got two inequalities here, and we're going to graph them in the domain of integers. So we've got negative x minus 4 is less than or equal to negative 1. So we're going to add 4 to both sides. So we get negative x is less than or equal to 3. Can't have a negative sign. So we multiply everything by negative 1. It's going to get the opposite of every one of these. So the opposite of this is this. It flips the sign also and makes this the opposite of positive 3 is a negative 3. So here is one of the things that we need to graph. So now we have the other one, x minus 1 less than 1. Add 1 to both sides. X is going to be less than 2. So if x is greater than or equal to negative 3, and it's also less than 2, we can write that as a conjunction. So x in the middle, since x is greater than negative 3, it's going to go in this direction. So we can put negative 3 is less than, x is greater than negative 3 or equal. So that is this flipped, right? Now we can just move this down here, and that's what we're going to graph. In the domain of integers, x is greater than or equal to negative 3. So we include negative 3, right? But it's less than 2. So we don't go up to 2, we stop at 1. And then we would take all of the integers in between. That's how we would graph that. All right, our next problem is negative 1 is less than x minus 1, which is less than or equal to 3. So what we're going to do is we're going to treat this like a 3-part equation. Whatever we do to one part, we do to all 3 parts. So we're going to add 1 to get x by itself, and we're going to do that to all 3 sections. So we get 0 is less than x, which is less than or equal to a positive 4. All right, so if 0 is less than x, we circle the 0. And if it is less than or equal to 4, we circle the 4 and we fill it in. So then we're going to draw a line from 0 to 4. And that's how we would graph that solution. And we do that because it's reals. That's why we circle it and we draw the line. Next problem. All right, so here is the next problem that you had incorrect. So we're going to do the same thing we did before. We're just going to rewrite it and solve it for x. So this is going to be adding 5 to both sides, which gives us a negative x less than or equal to 2. Multiply everything by negative 1 because we don't want a negative x, we want x by itself. That gives us the opposite of that, the opposite of that, the opposite of that. Now we solve for the second equation, or inequality. I keep saying equation. All right, so we're going to add 3 to both sides. X is less than 4. So now we're going to look at our numbers and see how we need to graph that. So if x is greater than negative 2, I can put x in the middle and make x is greater than or equal to negative 2, and x is less than 4. So if x is greater than or equal to negative 2, I can include, I'm going to circle and include negative 2. And if it is x is less than 4, I would circle 4, but our domain is integers. So I'm just going to go to the next integer, which is 3, and I'm going to put a dot on all of the integers that are included in the solution set. So from negative 2 is included because it's less than or equal to x. So it's included. 4 is not included. X is less than 4. The next integer less than 4 is 3. So this is the way we would graph this solution. Let's look at the next problem. All right, so here we have a negated inequality. So remember, we always write that. We don't write it for what it's not. We write it for what it is. So that would be negative x is less than a positive 2. So we would multiply everything by negative 1. That gives us x is greater than a negative 2. And then we have negative x is less than 1. So we multiply that by negative 1. X is greater than a negative 1. So I don't see how we can graph this. So if x is greater than negative 2 and x is greater than negative 1, so this is going to be an OR statement. So x is greater than negative 2 or x is greater than negative 1. So I believe that's going to be this one. I believe that's what that's going to be. Let me double check. Okay, so we would start at the negative 2 because, I had to go look it up, because this includes, this one includes this one. So because this one includes this one, it's going to be the one that gives, the best answer. It gives all of the answers, where this one is more limiting. This doesn't include all the answers. So we would circle the negative 2 and we would go this way and we would graph that. And the reason we do that is because it's reals and because there's no equal sign under here, we leave it an open circle. Next problem. Okay, so I remember doing this with you one day. I know we did this. I think you've just forgotten to go back and put your answers in. So I'm going to do this over here very quickly and just go back through it one more time, just for funsies, because it's so fun, right? All right, so let's see. I see two things that we can cancel to do elimination. So x minus 2y. Let's just call this A, B, and C. That's going to help us keep it straight, which one is which, right? So x minus 2y plus, we're using A here, plus 2z is equal to 2. And then we have C, we're going to use C, 3x minus 2y minus 2z is equal to 2. So then that gives us 4x minus 4y, this cancels, is equal to 4. Okay, so remember we talked about, I remember us doing this, when we have a coefficient that we can divide, that we can reduce, we're going to divide everything here by 4. Because if we do the same thing to every term, it doesn't change the value. So this is going to be x minus y equals 1, right? So there we go. So now we could add y to both sides and find that x is equal to 1 plus y. Now we have a substitution value that we can use for other things. We're going to call this substitution value, actually we're not going to call it anything, it's just going to be a substitution value that we can use later. So let's use A again, x minus 2y plus 2z is equal to 2, and I'm going to take b and I'm going to multiply b by the number 2. 2 times b, that's going to give me 2x plus 2y minus 2z is equal to 6, because I multiplied everything here. Put a 2 in front of each of these and multiply that by 2. So now when I combine those, this cancels and this cancels. I have 3x is equal to 8. So I'm going to divide everything by 3. X is equal to 8 over 3, and that is correct. That is correct. Okay. We also have a substitution value over here of x is equal to 1 plus y. Well, guess what? We know what x is. We don't need this anymore. So I'm just going to change it to where it substitutes for y. So I'm going to subtract 1 from both sides, and I have x minus 1 is the value of y. So now I have a substitution for y. So that's going to help me out a lot. So what I can do is I can actually take this value for x and put it in here, 8 over 3. And I'm going to turn this into 3 over 3 because that's a value of 1 is equal to y. 8 minus 3, that's 5 over 3 is the value of y. Now that I have x and I have y, I'm going to take b and substitute in. So x is 8 over 3 plus y, which is 5 over 3, minus z, which we don't know. And I'm going to take 3 and I'm going to turn it into a fraction over 3. So that's going to be 9 over 3. Now that everything has the same denominator, that's going to make life a little bit easier. In fact, I'm going to do the same thing to z. I'm going to multiply z by 3 over 3. So that's going to be 3z over 3. Now I can really do some math here. So I'm going to combine these two. That gives me, let's see, 13 over 3 minus 3z over 3 is equal to 9 over 3. So I'm going to subtract 13 over 3 from both sides. Negative 3z over 3 is equal to 9 minus 13. So it's going to be a negative 4 over 3. I'm going to multiply. Let's rewrite this to make it easier to see what we've got. We've got negative 3 over 3z. I'm going to multiply by the reciprocal. Right? So these would cancel. These cancel. These cancel. So I have z is equal to negative 4 over negative 3 makes that a positive. So 4 over 3. So my solution set is 8 over 3, 5 over 3, 4 over 3. That's my solution set right there. Alrighty. I know, yeah, fractions. But it is what it is, right? Those are the right answers. Next problem. All right, here's the next one. Again, this is going to be A, B, and C. So it's easier to identify which equation I am talking about. So I'm going to take B and I'm going to multiply B by negative 1. So that's going to give me a positive x, a positive 2y, a positive 2z, and 0 stays 0. It's either positive or negative. And I'm going to take C exactly the way that it is. X minus 2y minus 2z is equal to 4. That allows me to cancel and cancel. I have 2 x's is equal to 4. X is equal to 2. So there's my first answer. All right, so now let's see, what else can I do? Let's take A and we're going to multiply it by 2. Do we want to multiply it by 2? Yeah, let's multiply it by 2. So times 2, A. So it's 2x plus 2y minus 2z equals 6. And I am going to use B the way that it is. So I've got negative x minus 2y minus 2z is equal to 0. All right, so this cancels. This becomes x minus 4z is equal to 6. I know the value of x is 2 minus 4z is equal to 6. So I'm going to subtract 2 from both sides. That gives me a negative 4z is equal to 4. So if I divide both sides by negative 4, z is equal to negative 1. Now I have z. All right, so I can go up here to a and substitute. So x is 2. I don't know what y is. Z is a negative 1. So minus negative 1 would be plus 1 equals 3. So 2 plus 1, that's 3, plus y equals 3. Subtract 3 from both sides, y is equal to 0. There's my solution set. That one was pretty easy and pretty straightforward. So 2, 0, negative 1. So let's look at the next one. All right, so A, B, C, just so we can keep track of which ones we're talking about. So I'm going to use B and C first so I can cancel the y's. So B is x plus 2y plus 2z equals 3. And C is 2x minus 2y plus z equals 0. This cancels. 3x plus 3z equals 3. I'm going to divide everything by 3. X plus z equals 1. So that's going to let me make a substitution value of whatever I need it to be when we get to that point. So I am going to take a and multiply it by a negative 1. So negative 1 times a is going to give me a negative 2x, a positive y, a negative z, and a negative 2. And I'm going to combine that with c just the way it is. So it's 2x minus 2y plus z is equal to 0. That allows me to cancel my x's and my z's, and I get a negative y is equal to negative 2. So when I multiply both sides by negative 1, y is equal to a positive 2. So now I have something that I can use to solve. All right, I'm going to go back up to A. And, all right, right here, 2x minus y is 2 plus z is equal to 2. I'm going to add 2 to both sides. 2x plus z is equal to 4. So I think I'm going to make a substitution value for x by subtracting z from both sides. So it gives me x is equal to 1 minus z. So I'm going to put that into x. 2 is 1 times 1 minus z plus z is equal to 4. So 2 minus 2z plus z is equal to 4. So that's going to be 2 minus z is equal to 4. Subtract 2 from both sides. Negative z is equal to 2. So z is equal to negative 2. Now I can put that up here to get my substitution value. X is equal to 1 minus z. So minus the negative 2 would be plus 2. So x is equal to 3. So my solution set is 3, 2, negative 2. That's what I'm looking for. All right, and let me check. I think one of them is a duplicate problem. No, it's not. I must be thinking about a different lesson. All right, so again, we label them A, B, and C so we can keep track of which equations we're using. So I'm going to look and see if there's something that I can automatically cancel, and there is. I've got a positive 2y and a negative 2y. So we're going to use a like it is, and we're going to use c like it is. And combine those. So these would cancel. So I have 2x minus 4z is equal to negative 8. I can divide everything by 2, so I'm going to reduce this. And I get x minus 2z is equal to negative 4. So now I have a new equation that I can use. We're going to call this one d. All right, so I'm looking, and here I've got 2z right here. So I could actually cancel with d and b. So let's do that. I'm going to put b just like it is, and I'm going to say 2x minus y plus 2z is equal to 9. These two would cancel, so I'd have 3x minus y is equal to, oops, I did not do the math, did I? That would be 5. Negative 4 and a positive 9. So that's actually a new equation for us. That would be E. All right, so let me rewrite D for us. Let's put D over here. That would be x minus 2z equals negative 4. E is 3x minus y is equal to 5. So I'm getting closer, So what I need to do is create a substitution value, and I think I'm going to use that for, I'm going to use D for that. So for D, I'm going to add 2z to both sides, and that's going to give me D restated as x is equal to 2z minus 4. Because we're adding it to both sides, it becomes a positive number. Change sides, change signs, right? So now D is this substitution value. So I can take that out, and I can move that right back where it was. Okay, so D is now my substitution value. All right, and I'm going to do that into E. I'm going to say 3, and the value of x is 2z minus 4 minus y is equal to 5. So 6z minus 12 minus y is equal to 5. Add 12 to both sides, and that gives me 6z minus y is equal to 17. Okay, so that gives me yet another equation, f. I know, it goes on and on and on and on, doesn't it? So, all right, so I'm going to go ahead and let's see if I can do anything. Yes, I'm going to take E and I'm going to turn it into a substitution value for Y. I don't know if that's going to do me any good though. I need to cancel some more stuff is what I need to do. All right, let's take A and multiply it by negative 3 times A. That gives me negative 3x minus 6y plus 3z is equal to negative 3. And I'm going to use C just the way it is. That gives me x minus 2y minus 3z is equal to negative 9. All right, so negative 2x, negative 8y, these cancel. That's negative 12. Everything's divisible by negative 2. Get rid of all those negatives. So I have x plus 4y is equal to 6. That helps a lot because see, now I have an x and a y term over here. If I multiply E by 4, I get 12x minus 4y is equal to 20. That gives me 13x. This cancels. This is equal to 26. X is equal to 2 because 2 times 13 is 26. All right, I finally have a substitution value for x. So that's going to allow me to find the value of y by putting this in here. So 3, 2 minus y equals 5. 6 minus y equals 5. So negative y equals negative 1. Y equals a positive 1. I can put that into f. 6z minus 1 equals 17. Add 1 to both sides. 6z is equal to 18. Z is equal to 3. So x is 2, y is 1, z is 3. There's my solution. That took a while because I had to kind of play around with it. If I had done this one first, I'd have gotten there sooner, I do believe. But in order to cancel, I needed to find this one to put with that one. So this one over here, it was only good for helping me solve for z. So next problem. All right, we're almost done with lesson 8990. This is A, B, C. All right, so let's look and see what we can cancel right away. Okay. I've got a positive y and a negative y, so those will cancel right away. So let's do A and B. X plus y plus z equals 6. 3x minus y plus z equals 8. These cancel. 4x plus 2z is equal to 14. Everything is divisible by 2. So we're going to divide everything by 2. And that's going to be 2x plus z is equal to 7. We're going to call that D. And I'm going to take it and I'm going to put it over here before I lose it. There we go. So now it has a place to live. All right, so I'm going to try to find something else that I can cancel. So, I'll tell you what. I'm going to use A the way it is. So x plus y plus z is equal to 6. And I'm going to take c and I'm going to multiply it by negative 1. Negative 1 times c, that gives me a negative x, a positive 2y, and a negative z is equal to 0 because that doesn't change. So now this cancels and this cancels. I have 3y is equal to 6. So y is equal to 2. So that's a good start. I've already got one of my solutions set. Got the y. Let's see if that will help me get to the others. Okay, let's see, where can I put in y that will help me solve for x and z? I think I can use c. So let's take c, and I'm going to substitute in the value of y. X minus 2 times 2 plus z. This is a 2. That's my y value, is equal to 0. Okay, x minus 4 plus z is equal to 0. So x plus z is equal to 4 because I added 4 to both sides. Well, now I have 2x plus z. So what I'm going to do is I am going to multiply d by a negative 1. So that would be a negative 2x, and then that would be a negative z and a negative 7. So that's going to be negative x, this cancels, is equal to a negative 3. So x is equal to a positive 3. So now I have my x term. Now I can go back to d just like it is, and I can substitute in the value of x. So 2 times 3 plus z is equal to 7. 6 plus z is equal to 7. Z is equal to 1. So I was able to solve that fairly easily. Just have to use your logic and combine and eliminate, substitute wherever you can to logically solve for the other variables. It's really trial and error, just kind of putting them together and seeing what works. Let's do one more. I think you have one more in this lesson. Nope, that was it in that lesson. I think you also asked for help in lesson 118, so I'm going to go look at that. All right, this is the second problem in 118. That's the lesson we're in. So the first thing I see is we can divide everything by log 7. That cancels all of that. So what we have is x plus 7 minus x minus 2 is equal to 10, right? We're just canceling out the log 7 and leaving what's left behind. So in order to solve this one, I'm going to multiply negative. I'm going to apply the opposite to this. So negative 1 times all of this. X plus 7 minus x plus 2 is equal to 10. So that's going to be x minus x. Seven plus 2 is 9. 9 does not equal 10. So this problem does not work very well, does it? Let me see what's going on with this problem. I know what this problem is. I completely forgot because I'm old. Subtraction is division. That's the thing I forgot. So yes, we cancel these. Those go away. But subtraction is division in logarithm problems. So we have x plus 7 over x minus 2 is equal to 10. That's the way it's supposed to be formatted. I am so sorry. My brain just skipped a beat for a second. You know how old I am. All right, so we want to be able to solve this, right? So we have x plus 7 divided by x minus 2. So what I need to do is I need to get rid of the denominator. So I'm going to multiply both sides by x minus 2. So this would cancel. So I have x plus 7 is equal to 10x minus 20. So if I subtract x from both sides and I add 20 to both sides, this cancels, this cancels. So 27 is equal to 9x. So if I divide both sides by 9, 3 is the value of x. And that is the correct answer. Okay, so that's what it is. I just forgot when dealing with logarithms that minus means division and addition is multiplication. So it's just one of those things you have to, it's not a straight problem. It stands for something else. And you have to remind yourself that logarithms are just stupid. They're just stupid, and they have their own stupid little way of doing things. And so we just do the stupid little logarithm the way the logarithm wants to be done. Okay, I'm done. I don't like logarithms. I don't know anybody else that loves them either, except for really, really nerdy people. Okay, all right, moving on, getting off my soapbox. Next problem. All right, 7/16, so 7 over 16 of the assembled throng squatted in place. If this many did not squat in place, how many did squat in place? We want to know how many did, right? And this many did. So 7 over 16 did. So if the total amount of people is divided into 16ths, and 7 out of 16 did, then that means that 9 out of 16 did not. And that's going to equate to this number here. So we're going to say 9 over 16 is equal to 63.99 over some total number, right? This is the total ratio. This is going to be the total number of people. And then once we figure out the total number of people, we'll get the difference to figure out how many squatted in place. So we're just going to cross multiply, and this is going to equal 16 times 63.99, whatever that is. So x is going to be equal to 16 times 63.99, or 16 times 63.99 divided by 9. So x is equal to, now I'm just going to grab my calculator. This is much faster than trying to stop in between. 16 times 63.99 equals, divided by 9 equals 11,376. That is the total number of people. Okay? That we have. This many did not squat. This number right here. So minus this number right here that did not should equal the ones that did. So minus 6399, 4,977 that did squat in place. That should be your 7 over 16. That's 7/16. That's did squat in place. Okay, so there's that problem. It's just a little bit of a logic problem. The math itself is just a proportion. We know how to do those. You just have to figure out what is the question actually asking for in order to answer it appropriately. Let's look at the next. All right, a two-digit counting number has a value. All right, so we got a two-digit counting number. It's got a tens place and a units place, right? It has a value that is 1 greater than 8 times the sum of its two digits. Okay, so its value, that means 10 times the tens units plus whatever the units, the ones units is. All right, this is going to be 1 greater, so we're going to add 1 to 8 times the sum of its two digits. So 8 times t plus u. Okay, there's its value. If 3 times 10's digits, so 3 times t, is 11 greater than the units, so 11 plus the units, what is the number? All right, so we have the ability to create a substitution value for u. Do you see it? I'm going to just subtract 11 from both sides. And I'm going to rewrite it. U is equal to 3t minus 11. Right? 3t minus 11 is the value of u. So now I can put this in for all of the u's. But first I'm going to distribute. I am going to go ahead and put this in. 3t minus 11 is equal to 1 plus 8 times t is 8t. And 8 times u is 8u. All right? We can go ahead and put this in for u. 3t minus 11. All right, 10t plus 3t is 13. T minus 11 is equal to 1 plus 8t plus 24t minus 88. So if I add 11 to both sides, right, this would cancel. And if I combine these two, that's going to be, well, let's just get there. 13t is equal to, all right, that's going to be negative 88 plus 11. That's going to be negative 77 plus 1. that's going to be negative 76. 8 plus 24, that's going to be plus 32t. So if I subtract 32t from both sides, there we go. This cancels. That's going to be so 32 minus 10 would be 22. 22 minus 3 is going to be a negative 19. T is equal to negative 76. Divide both sides by negative 19. T is equal to what? 76 divided by 19 is 4. Negative divided by negative is a positive. So T is equal to 4. So 3 times 4 minus 11. U is equal to 12 minus 11, which is 1. So T is 4, U is 1. The answer is 41. Next problem. All right, we got another one of these stupid little problems right here. So we're just going to put LN in front of both of these, right? That's what we're going to do. And I'm going to pull up my calculator because it actually works, unlike the one in this program. Let me all clear this. All right, so LN, and then I have 23,354. This little button right here is going to give me times 10 and give me the opportunity to put in the exponent. This is the number I'm looking for. So now this becomes e to the negative 1.45. Now I'm going to do this number. Notice I'm just typing it in the same way it is. The LN key, and then 45633 times 10 to the 4th power equals. So 19.94, because this is going to round up. 19.94. All right, now this one at the bottom, E. I'm going to use the LN key. So let me pull up my calculator. LN 35139. Close parenthesis equals 10.46 with a 7, so we're going to round that to 10.47. So 10.47. All right, so all I'm going to do is add these together, and I can do that on this calculator. 19.94 minus 1.45. So that's going to be e to the 18.49. And when I bring this one up to the top, it's going to become a negative, right? So right here, it's like this. But I can do that and say minus 10.47. So minus 10.47, my answer is going to be E 8.02. That is one of the answers. So you're going to type E to the 8.02 is equal to, and I'm going to get my other calculator because it does a better job. All clear here. So E to the 8.02, actually, clear. All right, 8.02 E. E to the 8.02. That's what I'm doing. Equals. That's the number I'm looking for. I'm going to round this to 2 digits. This is going to be 18. 3041.18. So 3041.18. This is what you want to type in. That is your answer that you're looking for. Okay? All right. All right. This says to graph the solution xy, this point, where it's a member of the reals on the with 2 reals with 2 number lines. So R2 just means you've got an x-axis and a y-axis. You've got 2 number lines. That's what that means. So we're looking for the x-axis and the y-axis intersection point that is a member of the Cartesian coordinate system. So we have x plus y is greater than or equal to -3, and we have x minus 2y is less than -4. Right? So what we want to do here is think of this as a linear equation. This is a linear equation. So we're just going to graph this line. So what we're going to do is we're going to subtract x from both sides. So y is greater than or equal to -x minus 3. This is the first line you're going to graph. So this -3 is where the first point is. And now we look at the slope. It's negative, and it's 1, the invisible 1. So it has a slope of -1 over 1. So that means it's down 1 over 1. So this line is going to come right in here. Right? Okay, this line. So we're going to subtract x from both sides. That gives us a -2. Y is less than -x minus 4. Now we're going to divide everything by -2. Okay, so this would cancel. Y, this would make this flip. Whenever we divide or multiply by a negative number in an inequality, the sign flips. So this is a invisible 1 here. -1 over -2 is a positive 1 over 2. X, -4 divided by -2 is a positive 2. So this is our place on the y-axis. And our slope is up 1 over 2. So up 1 over 2, up 1 over 2, right? And we can follow that same pattern all the way back. Okay, so the first line has an equal sign under it. So this is going to be a solid line. That's how you're going to graph that. You will make a solid line here. This line does not have an equal sign under it. So these are going to be dotted. So you're just going to make some dots to show where they would fall. Just kind of fill it with dots. Okay, so you have a dotted line and you have a solid line. Now we look at the inequality. We're going to shade. Remember the shading bit? Y is greater. This is the solid line because it has the equal sign. So we want all of the points above. So that would be above and above, right? This one says y is greater than the dotted line. So that would be all of the points above the dotted line. So that'd be this area and this area. So the place that is true for both of those areas, for both of these sections, is the place that is above both of the lines. So this section in the top. So I'm going to get rid of this right here and this right here. So it's going to be the part in the top where the lines intersect in that space above, okay? I know this is not the right size graph. It's just one that I happen to have that I could put in for you. On your graph, this is going to extend like that, and you're going to fill in all of this. Okay, all right. I'll even show you on my answer key what that looks like. Looks like that right there. That's what it's going to be. You have a dotted line here, solid line here, and the top part is what is shaded in. Let's look at the next one. All right, this one is a perfect cube. So we are going to uncube it. So uncubing it would give us x, this divided by 3 is 2, and this divided by 3 is 1. So that stays the same way. Minus This with cube root of this is going to be 3 times 3 times 3. So that would be a 3 here. This divided by 3 is 2. This divided by 3 is 3. So this is the first thing. This is the second thing. When you have a minus here, then the rest of these are pluses. This is the second form. So now we take the first thing squared. So it's going to be x to the fourth y squared. Now we take the first times the second. So we move the coefficient to the front. Let me see if I've got this in the right order. I just realized that I did all of that problem without recording it. So this is the answer to the next problem. There you go. We uncubed each one of these, and then we squared this one and put it here. We multiplied this one times this one and put it in the middle, and we squared this one and put it here. That's it. Whenever you have the minus sign in the problem here, it goes in the front binomial, and then the rest of these operations are pluses. That is the second form. Next problem. All right, I'm going to remember to actually record this part. All right, so we're going to put this in the right order. This needs to go second. So we've got negative 5 plus the square root of 2 over 3 minus 2 times the square root of 2. Now we're going to conjugate this. So 3 plus 2 times the square root of 2 over 3 plus 2 times the square root of 2. That just looks like a z. Let me make that more like a 2. All right, so I'm going to, now that this is more complicated, I'm going to actually split this up as well. So negative 5, 3 plus 2 square root of 2, and square root of 2, 3 plus 2 times square root of 2. This is the numerator. So I've got a negative 15 and a negative 10 square root of 2. And I've got a positive 3 square root of 2. And 2 times square root of 2 times square root of 2 is 2. So 2 times 2 is 4. Positive. So this would be a negative 9 minus 7 times the square root of 2. Nope, it would not, would it? Because Miss Tracy can't subtract, apparently. Negative 11, sorry. All right, so negative 15 plus 4 is negative 11. So that's going to equal negative 11 minus 7 times the square root of 2 in the numerator. Let's look at the denominator. So that's going to be 3 times 3 plus 2 times the square root of 2, and then negative 2 square root of 2 times 3 plus 2 times the square root of 2. All right, 3 times 3, that's going to be 9. 3 times 2, that's going to be a positive 6 times the square root of 2. Negative 2 times positive 3 is going to be a negative 6 times the square root of 2. Negative 2 times 2, and then we have square root of 2 times square root of 2. So we've got 2 times 2 times 2, and it's negative. So that's going to be a negative 8. These cancel. That becomes a positive 1. So if we have a number over 1, that means that we have a whole number. So the answer is negative 11 minus 7 times the square root of 2. It is not a fraction, it is a whole number. Or it's 2 whole terms, I should put it like that. And that's the last problem, and it only took us an hour to do these 2 lesson sets. So if you have any other questions, please message me. We'll try to get these done. Pods will remain open a little bit longer than the first day. In fact, we'll probably leave them up until the end of May so that you can finish and finish well. So don't stress out about time, okay? I know we're going to have our last day of the school year coming up pretty soon, but we will give you the opportunity to finish those. And I'm sure you don't want to do it all summer, so you're going to want to go ahead and knock it out in your own time, but as quickly as possible while getting your best grade, right? While getting your best understanding. The good news is this is the last math we have at Growing in Grace. So you'll be done unless your mom says you have to take something somewhere else. So don't tell her I said that. Don't give her any ideas. All right, girl. I will see you on Thursday. Bye for now.